Good morning. Today's topic is electromagnetic spectrum. So, electromagnetic spectrum consists of different electromagnetic radiations. Okay. So, what is electromagnetic radiation? Electromagnetic radiation means when electrically charged particles moves under acceleration, alternating electrical and magnetic fields are produced, and these are transmitted in the form of waves. These radiations are called as electromagnetic radiations. Electromagnetic radiations. Okay. So, these electromagnetics forms alternating electrical and magnetic fields. These electrical and magnetic fields are perpendicular to each other. Electrical fields and magnetic fields obtained are perpendicular to each other. Also, these are perpendicular to the direction of propagation. Okay, perpendicular to the direction of propagation. So, if the direction of electrical fields is in x-axis and then magnetic field will be in y-axis, that is perpendicular to each other, then direction of propagation will be in z-axis. So, these three are perpendicular to each other. Now, these electromagnetic radiations, they travel with a velocity of light in vacuum. Velocity of light in vacuum, and velocity of light is represented as c, which will be equal to 3 into 10 raised to 8 meter per second. Okay. Next, electromagnetic radiations has both particle nature and wave nature. Okay, particle nature and wave nature. Okay, so wave nature, with respect to wave nature, the electromagnetic radiations having the frequency nu, which will be equal to c by lambda, where lambda is the wavelength. Okay, wavelength is the distance between two consecutive waves. And what about frequency? It is the number of waves passed at given point in 1 second. Okay, which is called as frequency. So, frequency will be equal to c by lambda. Now, according to particle nature, these particles are called as photons. Okay, and these photons possess certain amount of energy. They possess certain amount of energy referred to as quantum. Okay, so quantum amount of energy represents the photons. So photons possess quantum amount of energy. It is this energy is represented as quantum. Now, according to Max Planck, that is, this electromagnetic radiation possesses both particle nature and wave nature. So, according to Max Planck, E, the energy possessed by these particles is proportional to nu. Okay, or we can say E is equal to some h into nu, where h is called as the Planck's constant. Okay, or we can write E is equal to hc by lambda. H is the Planck's constant. Okay, which is equal to 6.63 into 10 raised to minus 34 joule second. It is a constant. So, according to Max Planck, E is equal to h nu. Okay, and the unit of frequency is unit of frequency. second inverse or hertz. It is represented as second inverse or hertz. Okay, and nu bar represents the wave number which is equal to 1 by lambda. So nu bar is 1 by lambda, which is called as the wave number. Okay, and the unit of nu bar is centimeter inverse. Now, there are different electromagnetic radiation present. Okay, these are having different energies. So we have to arrange these electromagnetic radiation. So electromagnetic radiations are arranged as a spectrum called electromagnetic spectrum. So this spectrum is called as electromagnetic spectrum. So in an electromagnetic spectrum, different electromagnetic radiations are arranged according to their energies. Okay, so these are having different energies. Depending upon the energies, electromagnetic radiations are arranged in a spectrum called electromagnetic spectrum. Now let us discuss what is electromagnetic spectrum and how they are arranged. Okay, so this is the electromagnetic spectrum. The different electromagnetic radiations present in the spectrum are, first one, gamma rays, X-rays, UV rays, then visible light. This is the place where we can see different colors, that is VIBGYOR, from violet to red. Violet, indigo, blue, green, yellow, orange, red. These are the different colors. And violet is having the lambda, that is wavelength 400 nanometer, and red is having 700 nanometer. Next rays are IR. Next electromagnetic radiation, IR. Then microwave, radio frequency, then last one is long waves. Okay, this region where the radio station is working in this frequency. Okay, now gamma rays is having the highest frequency, 10 raised to 20, almost 10 raised to 20. Then it is decreasing. X-rays 10 raised to 18. Then this range is from 10 raised to 16 to 10 raised to 15. UV rays, visible light. It's a small region where we can see the different colors. Okay, next IR, microwave, then radio frequency. So frequency is decreasing from gamma rays to long waves. Okay, this represents lambda according to wavelength in terms of nanometer. So gamma rays is having least lambda, and it is increasing towards long waves. Okay, so this is the electromagnetic spectrum in which the different electromagnetic radiations are arranged according to their frequency. Okay, so this much about electromagnetic spectrum.